we're talking about functions, and we're in the relations and functions part of the course, of the notes, and we're finishing off topic 3.3 and going into 3.4. Essentially, we're just giving you more and more examples of functions and concepts related to functions. And so, today we'll start off with odd and even functions. It's not a major point, but still something that we would like you to know. It says, if I have a function, and we call it f for function, very imaginative, and we say if for all values, function minus x is equal to function x, then that's called an even function. Whereas if function minus x is equal to minus function x, then it's called an odd function. And you'll see why in a little while, why we have actually singled those functions out. But for the moment, let's just say, okay, these are some ideas that I have to get my head around. So for example, here it says, which of these functions is even or odd, or neither even or odd. So if I start off here with f of x is equal to 5x, now what I want to do is I want to check what is function minus x. So function minus x, everywhere I see x in here I have to put minus x. And we know that 5 times minus x is the same as 5 minus 5 times x. And so that is indeed minus function x. So function minus x is equal to minus function x. So that tells me this function is odd. So this is an odd function. So function f of x equal to 5x is an odd function. The naming's a little bit strange, and the reason for the name is a little bit advanced, so let's just stick to odd and even and not even worry about why they're called that. I might come back to that page in a minute, but just let me leave that there. Now the thing is, function minus x is we recognise it, it's a linear function, so its graph is a straight line through the origin, its y-intercept is 0, it's got a slope of 5. So we can draw it over here, if I can't quite go up high enough, but anyway, we'll go about here. So imagine that I had a straight line that did that. That would be the graph of 5x. Now, the thing about an odd function is this. If I pick my graph up and rotate about the origin 180 degrees, that graph looks exactly the same. Okay? And so that's one of the properties that we like of odd functions. I can say over here, for an odd function, the graph is, and to use the math speak, we say it's symmetric about the origin. So by symmetric about the origin, I mean pick the graph up, rotate it 100 degrees and put it down again. So all odd functions satisfy that property, that they're symmetric about the origin. We look at b, function minus x, and here I've got 3x squared plus 1. So function minus x is 3 times minus x all squared plus 1. Minus x all squared is the same as x squared, doesn't matter which value of x you use there, so I can say that's the same as 3x squared plus 1, and so that is the same as f of x. So f of minus x is equal to f of x, so this one is an even function. This is an even function. Now, if you look at this function, last time we said, look, this is a quadratic function, it's got x squared in it. The graph of a quadratic function is a parabola. This particular parabola, because it's plus 3, is concave up. It has a y-intercept of 1, so it goes through here. And in this case, its vertex is at negative b on 2a, so its vertex is actually the y-axis. So this thing, I'm not very good at drawing parabolas, but anyway, it goes up like that on that side, and like this on this side. So that's the graph of y is equal to 3x squared plus 1. And that's not so easy to see up there. But this one is symmetric about the y-axis. And that's true of all even functions. So this graph is symmetric about the y-axis. And it's those two properties that we're actually interested in, being symmetric about the origin, being symmetric about the even axis, the y-axis I should say. So if I now go here to part C, it says look at the function, the function is f of x is equal to 0, so I should go here f of minus x. Wherever I see x in there I have to put minus x. Of course, there are no x's in there, so function minus x is also equal to 0. And that's the same as function x. It's also the same as minus function x. So the function f of x equal to 0 happens to be both odd and even. So this is both odd and even. And in fact, it's the only function that is. If I can just go back to the previous example in here, or the previous two examples, just say I chose a value for x. It doesn't matter, just say I chose x equal to 1. You can see there is function 1. I go up to the function across, so that's function 1. Now if I go to minus 1, go up to the function, it's also the same value, 4. So function minus 1 is the same as function 1. Both of them have value 4. And that's what we mean here. Function x and function minus x, they're the same value, no matter what value of x you choose. Hence it's symmetric about the y-axis. Whereas with the first one, I said function 1 was 5, whereas function minus 1 was minus 5. So you go across and then you go down. Hence it's symmetric about the origin. For this one, function x is equal to 0. That's just the x-axis, so here it is, going across here. That's y is equal to 0 there. You can see that it's symmetric about the y-axis. It's also, if I were to turn that upside down and do that, looks exactly the same, so it's symmetric about the origin as well. But that's the only function that can be both. The last one there is 3x plus 2, d. Let's have a look at function minus x. It's 3 times minus x plus 2, so I get minus 3x plus 2. That's not function x, so it's not equal to function x, so it's not even. Minus function x is minus 3x plus 2, and that's minus 3x minus 2. So it's not equal to function minus x either. So this function is neither odd nor even. So neither odd nor even. And so actually being odd or even is in fact rather a special case, really. Most functions are in this category, neither odd nor even.